Hello, my name is Noah Abji, and today we're going to learn how to multiply powers of 10 by decimals when those powers of 10 are in exponent form. So first, what exactly are powers of 10? Well, powers of 10 are when you multiply 10 by itself a certain amount of times. So those are numbers such as 10, 100, and 1000. Here's why. Basically, powers of 10 is when you raise 10 to an exponent. An exponent is the small number you see in the right-hand corner up here. Now, what this means is you're going to multiply 10 by itself a certain amount of times. So when we have 10 to the power of 2, it means 10 multiplied by itself twice. So there's two 10s total. And that means 10 times 10, the first 10 and the second 10, and that multiplies to get 100. 10 to the power of 3 means you have three 10s that you're multiplying. 10 multiplied by itself 3 times total. So you have 1, 2, and 3 10s that you're multiplying by each other to get 1000. The small numbers in the top right-hand corner are called exponents. And we call these numbers, the result, powers of 10. 10, 100, and 1000. But we can also express them in their exponent form, which is when we leave numbers such as 100 as 10 to the power of 2, or 1000 could be left as 10 to the power of 3. If we were talking about 100,000, for example, 100,000, this would be 10 multiplied by itself 5 times total. So instead of writing all these zeros out, we could write 10 to the power of 5, because it means 10 multiplied by itself 5 times total. And that's a little bit more simple and a little bit shorter, which makes exponent form really nice to work with powers of 10. Additionally, you might have also noticed that I 10 to the power of 1 here. Anything to the power of 1 is equal to itself, because it means you're only multiplying it by itself one time, or you have 1 10 total. So you're just left with 10 for 10 to the power of 1. So now that we know how powers of 10 work in exponent form, we're going to learn how to multiply them by decimals. And the best place to start is by talking about, first, how they multiply by whole numbers. Now, powers of 10 are actually really easy to multiply by whole numbers. And that's because all you have to do is add zeros to the end. The digits don't change. So let's look at some examples. When we multiply 13 by 10 to the power of 1, we get 130. We still have the 1 and the 3, but we have 1 0 at the end. When we multiply 41 by 10 to the power of 2, we get 4,100. We also still have the 4 and the 1, except now we have 2 zeros at the end. And same for 26 times 10 to the power of 3. We don't change the digits. All we do is add zeros to the end. And here we have 3 zeros that we added to the end. So the way that this works is we add the amount of zeros as are in our exponent. So for 10 to the power of 1, the number in our exponent is 1. So this means we're going to add 1 0. So 13 with a 0 added to it is 130. For this example, 26 times 10 to the power of 3, we have a 3 in the exponent. So this means we're multiplying 10 by itself 3 times, 10 times 10 times 10. And that means we're going to add 3 zeros to the number we're multiplying it by. 26 with 3 zeros at the end is 26,000. And with this example, 41 times 10 to the power of 2, since we have a 2 in the exponent, we add 2 zeros to the end of the number we're multiplying it by. So that is 4,100. Now here's the thing about decimals. Even though with whole numbers we can add zeros, it doesn't quite work the same with decimals. And that's because if you just add zeros to the end of decimals, you don't actually change the value. So there's going to be a new rule for multiplying powers of 10 by decimals. So here's what I mean. Let's say we have the number 2.1. Now, no matter how many zeros we add to the end, we're not actually changing the value. 2.1 is the same as 2.10. You added 1 0 here, which is equal to 2.100, so you added 2 zeros here. And that's equal to 2.1000000 and so on. You could add a million zeros, and the actual value of the decimal wouldn't change. So unlike with our whole numbers, we need a new rule for multiplying by powers of 10. Now similarly, it's really easy. Instead of adding zeros, we do what's called moving the decimal point. So we move the decimal point one spot to the right for the number in the exponent. So let's do some examples. So first, let's do this middle one, 0.352 times 10 to the power of 2. The number in the exponent is a 2. So instead of adding 2 zeros, we're going to move the decimal point 2 spots to the right because there's 2 in the exponent, so we move it 2 spots. So here's what that looks like. We move it 1 spot, 2 spots, 2 spots to the right. So instead of 0.352, it's 35.2. And again, the digits aren't going to change. For this example, 4.3 times 10, since it's 10 to the power of 1, that's equal to 10, we only move the decimal point 1 spot to the right. So if we move it to the right, we get 43 with the decimal point at the end, except we don't need the decimal point because that's just equal to 43. And with this example, this one's a little bit tricky. We actually have a negative number in the exponent. Now here's what this means. Instead of moving the decimal point to the right, we're actually going to move it to the left because we have a negative number in our exponent. So we move it negative spot to the right, which is to the left. So let's move it 3 spots to the left. So we get 0.918, and I'll draw the zeros in here. So we get 0.918, 0.0918, 0.00918. So our final answer for this one would be 0.00918. And when you have a negative number in the exponent, remember, you move the decimal point to the left instead of to the right. All right, and finally, we're going to do a review question. If you'd like to give it a try, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answers to these questions were 14.8, 272.7, and 0.000100183. All right, so let's do these questions out. Starting with the first question, we have 1.48 times 10 to the power of 1. Now remember, our rule with decimals is that we're going to move the decimal point 1 spot to the right for the number in the exponent. So the number in the exponent here is just 1, which means for this one, we move the decimal point 1 spot to the right, and it's no longer 1.48, it is 14.8. For question 2, we have 0.002727 times 10 to the power of 5. So since we have a 5 in the exponent, we move 5 spaces to the right. All right, and so what that looks like is we move the decimal point 1, 2, 3, 4, 5 spaces to the right, and we end up with it here. Now these zeros at the beginning don't mean anything anymore, so we have 272.7 as our final answer for this question. And for question 3, we have 1.00183 times 10 to the power of negative 4. 10 to the power of negative 4. Now remember, we moved the decimal point 1 spot to the right for the positive number we have in the exponent. So this means we're going to move it negative 4 spaces to the right, which actually means we're moving it to the left. We're going to move the decimal point to the left. Now sometimes this is hard to imagine when there's no numbers over here on the left. So we can just write in a bunch of zeros so we have numbers to move it with. And I'll show you what this looks like. We're going to move it 1, 2, 3, 4 spots to the left. And so that ends us with 0.000100183. And that is our final answer for this question. That's all, and thank you for watching.